Momentum is the quantity that describes how much motion a moving object has. In plain words, momentum equals mass times velocity. In symbols, we write this as P equals m times v. The impulse momentum theorem connects a force acting over time to a change in motion. In plain words, impulse equals change in momentum. In symbols, we write this as J equals mv final minus mv initial. Conservation of momentum is a rule that applies whenever no outside force acts on a system. In plain words, total momentum before a collision equals total momentum after the collision. In symbols, we write this as m1 times u1 plus m2 times u2 equals m1 times v1 plus m2 times v2. Now let us look at a worked example using this rule. A ball of mass 2 kilograms is moving at 6 meters per second. It collides with a second ball of mass 3 kilograms, which starts at rest. After the collision, the first ball continues in the same direction, now moving at 1 meter per second. We want to find the velocity of the second ball after the collision. Step 1 is to state the conservation rule we will use. Total momentum before the collision equals total momentum after the collision. In symbols, this is m1 times u1 plus m2 times u2 equals m1 times v1 plus m2 times v2. Step 2 is to substitute in the known values. The first ball has mass 2 kilograms and initial speed 6 meters per second. The second ball has mass 3 kilograms and initial speed 0, since it starts at rest. After the collision, the first ball has speed 1 meter per second and the second ball has an unknown speed, which we will call v2. Substituting these numbers gives us 2 times 6 plus 3 times 0 equals 2 times 1 plus 3 times v2. Step 3 is to simplify both sides of this equation. On the left side, 2 times 6 is 12 and 3 times 0 is 0, so the left side becomes 12. On the right side, 2 times 1 is 2, so the right side becomes 2 plus 3 times v2. Now we solve for v2. 12 equals 2 plus 3 times v2. Subtracting 2 from both sides gives 10 equals 3 times v2. Dividing both sides by 3 gives v2 equals 3.33 meters per second, rounded to 2 decimal places. So the second ball moves off at approximately 3.33 meters per second in the same direction as the first ball. Now for the check step, to confirm this answer is correct. Total momentum before the collision was 12 from 2 times 6. Total momentum after the collision is 2 times 1 plus 3 times 3.33, which is 2 plus 10, giving 12. Since 12 equals 12, momentum is conserved, and our answer is confirmed correct.